Hello and welcome to this lesson on the Android ecosystem, SDK, and general app development. In this lesson, we will review the general environment of Android applications, and more specifically of developing applications for the Android operating system. Currently, Android runs on over 18,000 different devices throughout the world. These devices can be anything from your garden variety smartphone in your pocket, to smart refrigerators and microwaves running Android in your kitchen, and soon to be running on the very cars that take us to work. With this wide variety, the screen resolutions for devices can range from the lower end of about 120 dpi, which stands for dots per inch on a screen, to 640 dpi. The dpi value denotes the quantity of pixels within a physical area of the screen. The higher the dpi, the higher the resolution and sharper an image that screen can generate. Over 80% of Android devices are running the Jelly Bean version of Android or above. We'll get more into the different versions of Android later on in this lesson. Also, a whopping 40% of devices running Android right now are from the Samsung Corporation. Google created a delicious naming convention for their versions of Android. Each major version release of Android is given a recognizable name which follows in alphabetical order and is some type of dessert. They started out with cupcake and donut. But one of the first significant releases of Android was Froyo, which was version 2.2 of Android. In the Froyo release, Google introduced huge speed, memory, and performance optimization, as well as enabling push notification and other features like quickly switching between multiple keyboards and languages. After that release, Google poured more effort into upgrading the Android user interface and added implementations to allow for near-field communication, extra large size and resolution screens, and support for multiple cameras in their Gingerbread Android version 2.3 release. It was after Gingerbread that Google branched the Android operating system in order to create Honeycomb, Android version 3.0. Honeycomb was the Android version released specifically for tablets. It incorporated new elements to optimize applications for the new screen form factors, including the new holographic user interface. This version of Android was only available for tablets, but the components and new graphical user language will later be merged back for version Ice Cream Sandwich of Android. In this next release, Google jumped to another major version, introducing version 4.0 Ice Cream Sandwich. In Ice Cream Sandwich, Google migrated all of the new concepts and graphical languages and officially announced the Holo interface and design standards and the new Roboto font family. In addition to the graphical overhaul, Ice Cream Sandwich introduced better voice recognition. Now that a new graphical language is defined, Jelly Bean, Android version 4.1, was introduced to perfect that language and expand the features and interaction of the graphical user interface. In the Jelly Bean release, Project Butter was revealed. It introduced significant performance improvements by using touch anticipation, triple buffering, extended VSync timing, and utilizing a fixed frame rate of 60 frames per second in order to create a fluid and butter-smooth UI. As of KitKat, Android version 4.4, Google made another slight branch with version 4.4W, designed for Android Wear, Android's operating system designed for watches. In addition, the KitKat release included work from Project Svelte, which optimized Android to run on a greater range of devices. A new runtime called Art was also introduced as an experimental feature in Android version 4.4 KitKat. After KitKat, Google introduced a new protocol for Android version releases by releasing a preview of the upcoming release to developers. The developer preview for this version was referred to as Android L, the next consecutive letter in the naming convention, and it was made available almost 5 months before the official release of Android Lollipop version 5.0. Android Lollipop introduced a new graphical language named Material Design, as well support for 64-bit CPUs, major changes to the Android notification system, and other significant changes like defining the Art runtime as the default runtime in place of the previous Dalvik runtime. When designing applications for Android, it is important to keep in mind your target devices. You could be designing an application that only works on Android Wear for watches, or an application that would need to run on a range from small phones to large tablets. Whatever the case may be, these parameters can have major impact on the development process of your applications. Android allows for you to build your dream applications, ranging from exciting interactive 3D games to addictive and sleek social networks. Whatever your idea may be, Android development offers the tools to build it. The devices running Android can offer your application boundless points of data, including information about the user's location, their interaction with the device, images the user has previously made or stored on the device, selections of the user's audio files, and much, much more. Part of the Android infrastructure allows you to have limited releases or partial releases of your application. This includes the ability to start an alpha or beta testing program with selected users before having a full release of your application. Once your application is tested and polished to perfection, you can release it to the Google Play Store and make it available to millions upon millions of users. The Google Play Developer Console also gives you built-in analytics on your application, including total number of downloads, current number of active downloads, user-submitted crash reports, and statistical breakdowns of downloads according to Android version, country of download, language, app version, mobile carrier, and more. In addition to the data collected through the Google Play Developer Console, you can add your own analytics and data collection to your application in order to add features that your users want and upgrade your application to your users' needs. It is time to get started developing in Android. In order to do that, we will need an SDK, or software development kit, to build, compile, test, and analyze your Android applications. The Android software development kit includes Android emulators to test your software on a simulation of a wide range of configurations, screen sizes, and resolutions, debugging tools to help you find the issues in your application and fix them as soon as possible, analyzing and optimizing tools so that once you build your application, you can optimize it to reach its full potential in speed and performance. There are also a lot of documentation and actual Android source code available in the Android SDK. This allows you to learn from the actual developers of the Android operating system about naming conventions and code syntax. Starting to develop in a new language or platform can sometimes be daunting, but when starting in Android, we already have lots of code samples and applications packaged into the Android SDK to give us references and launching pads for our development adventures. In order to utilize the tools, documentation, and code of the Android SDK, we are able to utilize the Android SDK Manager, which is packaged with both the ADT plugin for Eclipse and Android Studio IDE. We will cover both of those in later lessons in this section. As we can see here, the Android SDK Manager allows us to browse several different types of available material. This includes Android build tools for building and compiling our applications, versions of Android, which includes system images, samples, special APIs, and source code files. Here we see the section for Android Release API 21, Android version 5.0.1, also known as Android Lollipop. We can also download previous versions of the Android SDK, APIs, documentation, and system images in the same fashion. Finally, we find the Extras folder. This will include special support libraries, additional tools, and drivers available for download through the Android SDK Manager. The SDK Manager itself is updated regularly with new information, updates, and fixes for previous versions.